you ever wondered why Mercury, the closest planet to our Sun, is often the least observed? It's a question that puzzles many of us, even those with a keen interest in the cosmos. Mercury, despite its proximity to the Sun, can be surprisingly difficult to observe from our home planet. This is because it's always found lingering close to the Sun in our sky. Imagine trying to spot a small light right next to a blindingly bright one. It's a similar challenge. This proximity to the Sun often means Mercury gets lost in its glare, making it less observable than planets that are further away. But this hasn't stopped us from learning about this intriguing celestial body. In fact, Mercury was discovered by ancient astronomers as far back as the 14th century. Yes, you heard that right, the 14th century. Back then, without the aid of modern telescopes, these astronomers had to rely on their keen eyes and clear skies to chart the stars and planets. And while Mercury is often hidden in the Sun's glare, there are certain times of the year when it becomes visible to the naked eye. These windows of opportunity, however, are brief and require careful planning to take advantage of. The best times to observe Mercury from Earth tend to be during twilight, just after sunset or just before sunrise, when the sky is dark enough for the planet to stand out, but the Sun is still below the horizon. So you see, observing Mercury is a bit like trying to catch a glimpse of a shy creature. It's there, close to the Sun, often hiding in its brilliant light. But with patience, planning, and a bit of luck, we can catch a glimpse of it in our sky. It's this elusiveness, this challenge, that makes Mercury so fascinating. It's a planet that's always been there, always close to the Sun, yet so often out of sight. But this hasn't deterred us. On the contrary, it's piqued our interest, fueled our curiosity. So while Mercury might be elusive to our eyes, it has certainly not escaped our curiosity. Now, imagine a world where you could experience the hottest and coldest temperatures in our solar system in a single day. Welcome to Mercury. Mercury, the closest planet to the Sun, takes the crown for the most extreme temperature variations experienced in our solar system. Picture this. During the day, temperatures on Mercury can escalate to a scorching 800 degrees Fahrenheit. That's hot enough to melt lead. But once the sun sets, the temperature plummets dramatically, reaching a bone-chilling negative 290 degrees Fahrenheit. You'd think you've been whisked away to the coldest corners of the universe. You might be wondering, how can a planet experience such extreme temperature fluctuations? The answer lies in Mercury's lack of a substantial atmosphere. On Earth, our atmosphere acts like a cozy blanket, trapping heat and moderating temperature extremes between day and night. But Mercury, with its virtually non-existent atmosphere, has nothing to hold on to the Sun's heat. So, when the Sun dips below the horizon, the retained heat quickly escapes into space, leaving the planet in a deep freeze. And speaking of day and night, Mercury's day-night cycle is not your typical 24 hours. In fact, a single day on Mercury from sunrise to sunset lasts a lengthy 59 Earth days. This means that the sun-baked side of the planet has a long, searing day, while the dark side endures a prolonged, icy night. But don't let these temperatures scare you away. Mercury's extreme climate is not just a testament to the planet's harsh conditions, but also a fascinating example of how diverse and dramatic our solar system can be. The inhospitable conditions on Mercury offer an intriguing contrast to the life-sustaining environment we're accustomed to here on Earth. So, while Mercury may not be the ideal vacation spot, it certainly makes for an interesting subject of study for astronomers and space enthusiasts alike. As we can see, life on Mercury, if we can call it that, would be quite a roller coaster. Ever wondered what the surface of Mercury looks like? Picture a landscape reminiscent of our own moon, heavily cratered and marked by the passage of time, but with its own unique elements that make it distinctly Mercurian. The surface of Mercury is a testament to the violent history of our solar system. Pockmarked with impact craters of varying sizes, it tells a story of countless celestial objects colliding with the planet over billions of years. The most prominent of these is the Caloris Basin, a massive impact crater spanning over 1,500 kilometers in diameter. That's roughly the size of Texas. This makes it one of the largest impact craters in the entire solar system, a testament to the sheer magnitude of the forces at work in our cosmic neighborhood. But Mercury's surface isn't just a tapestry of craters. It's also home to a unique feature known as scarps, or cliffs. These scarps are long, steep slopes that run for hundreds of kilometers across Mercury's landscape. The most fascinating aspect of these scarps, they suggest that Mercury, contrary to what one might expect, has actually shrunk over time. You might be wondering, how can a planet shrink? Well, as Mercury's iron core cooled and contracted over billions of years, it caused the surface to crumple, creating these scarps. Think of it like the skin of a fruit drying out and wrinkling over time. This process, known as global contraction, suggests that Mercury has shrunk by as much as 7 kilometers in radius since its formation. Quite an impressive feat for a planet that's already the smallest in our solar system, wouldn't you say? So while at first glance, Mercury's surface might seem barren and desolate, it's actually brimming with tales of cosmic collisions and planetary evolution. Each crater, each scarp, is a piece of the puzzle, a chapter in the grand narrative of our solar system's history. Mercury's surface, though barren and desolate, tells a fascinating story of our solar system's past. How do we know all this about a planet so close to the Sun and so far from us? Well, our understanding of Mercury has been greatly shaped by two major exploration missions, both launched by NASA. The first was the Mariner 10 mission, which took place over 40 years ago. In 1974 and 75, Mariner 10 flew by Mercury 3 times, becoming the first spacecraft to visit this planet. With each flyby, Mariner 10 captured images of Mercury's surface and gathered data on its magnetic field. This mission revealed that Mercury, despite being so small, has a magnetic field much like Earth's. Fast forward to the 21st century, and we launched the MESSENGER mission. MESSENGER, which stands for Mercury Surface Space Environment, Geochemistry and Ranging, orbited Mercury from 2011 to 2015. It gave us a wealth of information, mapping virtually the entire surface of Mercury and confirming that the planet has a global magnetic field. One of the most groundbreaking discoveries from MESSENGER was about Mercury's core. Scientists had theorized that Mercury had a large iron core, but MESSENGER provided the proof. It found that Mercury's core makes up a whopping 85% of the planet's radius, far larger than any other planet in our solar system. MESSENGER also revealed the presence of water ice in the permanently shadowed regions of Mercury's poles. Imagine that, water ice on the planet closest to the Sun. These missions have been instrumental in expanding our knowledge of Mercury. They have shown us that despite its small size and proximity to the Sun, Mercury is a world full of surprises and scientific interest. As technology advances, who knows what more we will discover about this enigmatic planet? The more we explore, keep questioning, and keep pushing the boundaries of our understanding. As technology advances, who knows what more we will discover about this enigmatic planet?